And welcome back to SP Channel, guys. It is Christmas morning, and I figured that I would like to put a video out. I'd like to give a shout out to my little nephew, Tucker D. I miss you. It's Christmas. I hope you watch this video. I know you will, though. Today we have my good friend TatePlays, and we're going to be talking about string theory and quantum physics and everything in between. And welcome to the show, Brother Tate. What is up?
Not much, brother. Merry Christmas to you.
And Merry Christmas to you. So, string theory. I would like to take that theory, and I would like to throw that theory under a bus, and I have my reasons. What do you know of string theory, Brother Tate? Would you like to talk about it?
Alright. This is the fundamentals of what I know about string theory. Way down, very microscopic particle, there are supposed to be these little strings, and if you were to vibrate one of these strings, you would be able to change molecule to molecule to molecule.
Well, okay, let's take it a step further. In string theory, in classical string theory, what you have is the smallest particles in the universe. And for particles to behave the way that they do in certain space-time, that there must be higher dimensional forces at work we just cannot perceive because they are a higher dimension. Now, these higher dimensional forces, in classical string theory, you have 10 dimensions, and M theory allows for 11, but you need these mathematical extra spaces for particles to react and behave the way that they do. At the nanoscale, the tiniest particles, we have these strings. They're smaller than a Planck distance. So basically what they believe gave particles mass was that these strings were vibrating, because you have to understand, at the atomic level, nothing really ever touches anyway, right? You realize there's this small electromagnetic barrier between any atoms, and that's why they form lattices and shapes as they do, because they don't truly touch. Okay, so at the smallest level, we have these strings. These strings are vibrating and causing the atoms with these vibrations to react and behave the way they do. But the deal is, string theory has a few flaws in it, and I'd like to discuss some of the flaws in string theory. The deal with string theory is that it was necessary. It's tied in with pilot wave theory. If the universe is quantum and duality is really the reality, then we have to understand how things can be in two places at once, hence the vibrations. Because how can something be in two places at once unless it's vibrating? The deal here is string theory has a few issues. It had a few problems from the beginning, but as early as 1919, as soon as Einstein published his theory of general relativity, there were other like-minded people like Theodore Kaluza. He was playing around with the concept of relativity within a five-dimensional space because, why not? It's how we do. What he discovered is that in that five-dimensional space, you can separate Einstein's relativity equations entirely into a fourth-dimensional component that looks a whole lot like general relativity, only without Einstein's equations. What he had discovered, a lot of the unified field theories were trying to describe the exact same principles, just using completely different methods, and weirdly enough, all of these different principles seem to all lead to this similar theory. And what really put the nail in the coffin for that was when you compared Kaluza's math to Maxwell's equations for electromagnetism, and they seemed an awful lot alike. So Maxwell kind of discerned that if electromagnetism looks a whole lot like these relativity components that Kaluza has created, then there must be a higher dimensional space working on particles, right?
Higher or lower, something that we cannot perceive ourselves.
Well, it couldn't necessarily be lower, because a lower dimensional space just wouldn't work mathematically. Remember how we talked earlier about the math of infinity and how you can add to it and it's still infinite, and you can take away from it, but you're still taking away infinity. The problem with that is lower dimensions, we're unable to conceive them. We're at least able to conceive these 11 dimensions in M theory that we spoke about, though. He kind of solved the issue by proposing that electromagnetism could react within the strong and weak forces of gravity if you account for extra dimensional spaces. So, we can kind of credit Oscar Klein in 1920 for coming up with the idea for particles to react the way they do, that there would of course have to be higher dimensions because nothing else could explain why particles react the way that they do.
It seems an unseen force, one way or another, is interacting. The math is sound, it's just...
See, the problem was, Klein came to the reasoning that these extra dimensions couldn't be from strings, that within each particle, instead of a string at the smallest possible scale, there would have to be these little loops. These little loops were where the extra dimensional forces were contained. Not some great universal size cosmic plane of existence that we couldn't grasp, but tiny, microscopic, and tied with each physical particle of reality, you see. So, fifth dimension, sixth dimension, and higher, those dimensions are possible, but the problem is they're microscopic, and they're tied in closely with each particle of mass in the universe. That instead of strings, we have these little loops, and these little loops contain, at microscopic levels, these higher dimensional planes. So it's kind of like a quantum particle storm of higher dimensional space than a entire other large unified reality. You see what I'm saying? Like, there is fifth and sixth and seventh dimension, but they're very tiny, microscopic, and curled into these little loops.
Holy schnackle. I've been thinking of these as a donut shape, which I'd seen in a video previously.
A donut shape is a nice, simplified way to envision them, but while they are a circle, they could take on any shape. They could be a circular spiral loop. They could be an infinity loop, a Mobius strip loop. Basically, the deal is that they're closed off and they contain these higher dimension. You know, they curl. You know, it could be just an infinite ongoing curl.
The thought that I had is theoretically maybe you could have these loops intertwined?
Because these atoms all possess a positive or negative charge, alright, these atoms are going to want to push away from each other. You know, kind of like magnets tend to do. So if you had this shape built out of all this positively charged matter, it's going to want to tend to push away. That kind of ties into chaos theory, how things break down in half-life. Truth of the matter is those atoms, they don't want to be in that formation. They want to go around randomly and just do their thing. The problem with string theory is this. We have these little loops, right? And within these little loops are contained these higher dimensional spaces, but it's like this quantum particle storm. But this is the reason that string theory is incorrect and it needs to be replaced with M theory. Because those little strings aren't little strings that vibrate, they're little loops that hold microscopic higher dimensional space. And we perceive that because it is higher dimensional, because we've spoken about dimensional theory before. A second dimensional being or a second dimensional drawing couldn't perceive the third dimension because it's just something beyond their reasoning and concept. They couldn't possibly perceive a higher dimension. It's a two-dimensional image, right? So the same factor applies to us. Now, a lot of people tend to think of us as third dimensional beings. We're simply not. There's a lot of discussion whether that should be redefined. We are fourth dimensional beings. We experience space-time, and that is the fourth dimension. We are fourth dimensional creatures. The deal with that is a fifth dimension. This fifth dimension, it would be something beyond our comprehension. People must accept that because of dimensional math, certain things are just going to be beyond our comprehension, and we may never be able to fully understand them. We know that those forces are there because of the way that particles react. We don't know what this force is, what this dimension is, what these higher dimensions really mean. We just know how it forces particles in this fourth dimension to react with one another, and that's how we know they exist.
So basically, with our own senses that we are born with, sight, sound, touch, we cannot perceive these dimensions.
We can only perceive those higher dimensions as electromagnetic or gravitational force.
So basically,
yeah, with any tools, with any senses we have. To understand it any deeper is beyond our conceptual reasoning. We are not fifth dimensional beings. We are fourth dimensional beings. That other dimension is beyond our comprehension, and forever shall it remain.
So the only way that we can explore it is with math.
Yes. The only way we can ever explore it is with math. the only way we can ever know it's there with math. We don't even have microscopes that can see down to the string definition yet.
Can we go down to Planck's?
Planck distance is one of the smallest measurable distances that we use in mathematics. Understand that the Planck distance is basically just a mathematical measurement. Things are perceivably smaller, but for mathematics' sake, our smallest definition of measurement is the Planck distance. But yes, things can get smaller.
That's what I thought, because beyond that you've got quarks, I believe.
No, quarks are actually much bigger than a Planck distance.
Really?
Yes, sir.
I thought they were smaller.
No, Planck distances are insane, man. You can even, you have to realize they take the Planck distance, but they can break that down to 1/1 billionth of a Planck distance. Within that Planck distance, they've got parameters.
Very true. I think that string theory needs an overhaul and a renaming.
The problem with string theory being renamed is when you rename it to ring theory, it's no longer string theory. The fact is that string theory and current M theory are two drastically different. The problem is string theory suggests that these higher dimensions are these vast cosmic planes of existence that we just can't reach because it's a different vibration. Look at television. Look at the things the media wants to express. Let's go to this other dimension. Wow, it's this whole other world with other people. It's not. These other dimensions are microscopic. They're tinier than the Planck distance. They're contained and connected with each particle of mass. This is why M theory allows for so much change. M theory is an adjustable, interchangeable theory. It allows you to take what we know and add to it and redact it as we need. M theory is the way to go because M theory is not perfect. M theory doesn't claim to have all the answers. M theory just claims that as we discover more, it will change and adapt to that.
The last I kept up with M theory, they would replace some of Newtonian mechanics with some of Higgs' work.
Because M theory allows that. M theory is, like you said earlier, M theory is like a plug and play.
At the very least, man, I would agree at the very minimal, they need to change a few things and rename string theory. But if you rename it, just like you said, it's no longer string theory, it's ring theory.
Well, it isn't just that. The fact is string theory makes completely different suggestions than what we're seeing. Since the 80s, it's gotten a few rises in popularity. One of the rises is the mass media induced romanticizing of there are these other dimensions and planes of existence where there's people and buildings just like you and a big cosmos to explore, but that's just not the truth. Time changes things. With fifth dimension is tied into these little loops. These little loops have tiny microscopic higher dimensional space which we perceive as an electromagnetic or gravitational force, but we don't fully understand it. We can't fully comprehend it. It's theorized that because it is higher dimensional reasoning, that it's just beyond our comprehension.
If you built this elegant set of mathematics to define something that's undefinable, why can't you define it?
The problem is there's an old idiom within the walls of scientific research. What is most important to you, Tate, as a person who values science, truth or beauty?
I would rather truth.
I would rather truth as well. String theory is beautiful, but it's just not true. It's impractical, and it doesn't fit the current modern data. We can choose string theory because it's beautiful. String theory is beautiful in this way. String theory gives us the idea of there's these other dimensions just like us, and other things are happening, and they have their own buildings and trees and dogs and cats. But that's just not the truth. The truth is there is higher dimensions. They're just microscopic, and they're tied in with these particles, and that's why the particles react in the way they do. Guys, I hate to call the conversation where we're at, but where we're at, it's Christmas morning, and I'm going to have to do a lot of editing to get this video ready, and it is going to be quite long on me. I hope to get it out by Christmas morning. I want to thank everybody for listening. I want to thank Tate for being here. I again Want to thank my little nephew Tucker D. I think about you all the time. For everyone that's tuned in, this was a special Christmas episode. But thank you guys for listening. Thank you guys for being here. Tate, is there anything you would like to say to the people?
Merry Christmas, Happy Holidays, and I hope you get through your family reunion.
Indeed. Well, I want to thank everybody for listening in, and make sure to tune in next time to Scientific Phenomenon. Hey, while you're at it, why not hit that subscribe button? Until next time, this is Scientific Phenomenon saying, a wise man once said,